All right, we have a first quarter benchmark in Algebra Foundations 2. And so here is our study guide. And it's going to span all chapter 6, pre-chapter 6, which was I don't know, a little bit of chapter 5, but all right, so here we go. Square root notation. I have rational exponents. A rational exponent is a fraction exponent. So I want to practice with you how to change from one to the other. It's been a while since we talked about this. If I have a square root, the little number, it's called the index, the little number inside the root, that becomes the denominator. The power becomes the numerator. So m over n. C to the power of m over n is the same as the nth root of c all raised to the m power. So it's a format. You're just memorizing that. If I have something like, let's do number 3 first. That's easier. 5 to the 2/3 power. The 3 denominator goes down and becomes the root. So this denominator down goes down and becomes the root. That's a good way to remember it. And the number that's closest to it, the 5 to the 2, the numerator of 2, stays with it. So it'd be like 5 squared. Or sometimes you might see the cubed root of 5, and then the whole thing is to the second power. Either way, the 3 is in the root position. That's the denominator. And the 2, 5 to the second, stays with it. Stays with the 5. Stays with the power. So that was number 3. Let's go backwards. The cubed root of 10. Number 1. Where does the 3 go? And I don't see anything. 10 to the what? You guys, 10 to the what power? What? There's no number here. What do I do? The first. It's a 1 that we don't write because writing 1s is a waste of our time. So I'm going to put a large 10. And I'm going to have a rational exponent, a fraction. Where does the 1 go? Where does the 3 go? Look at this. Where did the 2 go? Where did the 3 go? So now, where's the 1 going to go and where's the 3 going to go? This 1 that we don't really see stays with the 10. Where does the 3 go? It was down. 10 to the 1/3 power. So sometimes there's not going to be an exponent, but that's a 1. How about number 2? Write the 4th root of 6 cubed. The 4th root of 6 cubed. You do it. Where does the 3 go? Where does the 4 go? Go ahead. The 4th root of 6 cubed. Where does the 4 go? Where does the 3 go? It's 6 to the what power. And then write a fraction. Oh. Someone tell me out loud. 6 to the what? 3/4. And it's hard to make it small. I just got to make it small and on the upper right corner. Okay. So there's that. 1, 2, and 3. I'm moving on already. Number 4. I have to if the base is the same, set exponents so here's what that looks like. I have an x divided by 2 and an x divided by 2. The properties of exponents, remember when it's like x squared times x to the 5th, we do x to the 2 plus 5. Do you remember that? So I'm going to set the exponents into an equation. X over 2 plus x over 2 equals, and just a 6. X over 2 plus x over 2 equals 6. I get rid of the 5s. The 5s are gone because they're all the same base, so I don't need to worry about them. How do I clear fractions? I need to clear fractions. How do I get rid of those 2s? Yeah. I don't want to divide anything. I can't divide x divided by 2, a variable by a number I can't divide. I want to get rid of those 2s at the bottom. I don't want to cross cancel. Yeah? Multiply. I don't want to multiply straight across. You're on the right track. I multiply something, but I need a more description. Multiply everything by my common denominator. What's the common denominator of 2 and 2? 2. So I'm going to do this times 2. This fraction by 2. And the 6 times 2. I'm clearing the fraction. So this would be like, when you know how you multiply straight across, 2x over 2 plus 2x over 2 equals 12, right? Because when I multiply fractions, I multiply straight across. And then, well, what's 2 over 2, guys? Simplify 2 over 2, a number divided by itself. 2 over 2. 1. So just x plus x. These 2's become 1's. Equals 12. What's x plus x? What's x plus x? 2x. 2x equals 12. Awesome. And what does x equal? Divide both sides by 2, right? X equals 6. Okay. Do you remember how? I'm moving on. A times b to the x power. A is the initial amount, the y-intercept. Initial amount is the same as the y-intercept. And b is the constant ratio. Sorry about the photocopy. So the constant ratio means how is my graph changing by? If there's a number in front, that's going to be my y-intercept, my initial amount. Now, we haven't practiced graphing these. But it is important for us to be able to figure this out. So what I think that we should do first is graph one. Uh-oh. 7, 8, 9, 10. It didn't photocopy the back side. Mr. Diaz, I might have you do that. Are you able to do that? Yeah. Okay. I'll have to graph it on the side, but. I don't want these from it. Oh, can I get 60? What is this? 20? Yeah. Yeah. Okay. So 10 to the x. You're going to need to know how to graph this. So I will help you graph this. If I had to make a table of values, I was picking numbers way back when. I was picking numbers for you that were like really easy numbers. So that's going to be like, you know, -1, 0, 1. And honestly, that's the best I can do. I don't want to do 10 to the second power. 10 to the -1. I think I need more room, huh? So 10 to the -1 means what? What do I do with the negative exponent? 10 to the -1. Drop it down. Yep. Equals 1 over 10. 1/10. All right, 10 to the 0. What's anything to the 0 power? 1. What's 10 to the first? 10 to the first power. 10. Okay, easy. So, if I were to draw a little graph of this, -1 and up 1/10. 1/10 is not even to 1. 1/10 is like 10 cents from a dollar. True? 1 over 10. Small fraction. 0, 1. Because remember, this is really 1 times 10 to the x. So my y-intercept is 1. My y-intercept, 1. 0, 1. And then 1, 10. I don't even have 10 spaces to go up. Whatever, just make it high. Over 1, up 10. I can't even go up 10. Remember, it gets super close to the x-axis, to the asymptote. The asymptote is y equals 0. Super close to the asymptote, but doesn't touch it. My domain is going to be from left to right. Remember? Scan left to right. What do I got? Does it go forever up, 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 up to the right? What do I call that? The domain. Infinite, all real numbers, but it's -infinity to +infinity. And the range. The range, remember, is low to high. Nothing, 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 nothing. Oh, 0. But it doesn't touch 0, so I'm going to put a parenthesis, 0, and infinity. Or y is greater than 0. It could be written 2 ways on the benchmark, so you need to know both ways. Along the y-axis, it starts at, I start seeing the graph above 0, greater than 0. This second graph, I'm not going to have you graph it, but I want to let you know that this is the y-intercept. Yeah? 0, 2. Which means that if I graphed it, and let me show you what that looks like on a graph. 2 times 3 to the power of x. I'm going to switch over to the computer screen, guys. And I'm going to go on something Desmos. So 2 times 3 to the, oh. Okay, let's look at where my asymptote's going to be. It never, look at how close it gets to the x-axis. It never touches though. Even if I zoom in, guys, look at how close that is, but it never touches. It's never going to touch the x-axis. It's never going to touch y equals 0. Y equals 0 is the name of that x-axis. So, asymptote, y equals 0. My domain is still going to be all real numbers. And my range will be either, they'll label it as 0 to infinity, or y is greater than 0. Okay. Let's go to the page that we have next. 12. Okay. Choose all that apply. The only difference between these two equations is the exponent. One is to the power of x, and one is to the x plus 2. Let's remind ourselves what the x plus 2 does. So in a transformation, the x plus 2 is going to move it. Thanks. So the x plus 2 moves it left or right, but it's the opposite sign. So this graph is going to be 2 to the left of the original. 2 spaces to the left of the original. And they're going to have the same domain because they're going to go, let's do just like a sample. Here's my f of x. F of x. This is just a sample. You can just watch. And here would be g of x, 2 to the left. It's just like 2 spaces to the left. So they're going to have the same domain. This will eventually, even though it's 2 to the left, this will eventually go down, down, down. They're going to have the same range. Are they going to have, so if this is eventually going to hit 0, they're going to have the same asymptote, y equals 0. But just looking at it, does it have the same y-intercept? No. That's the one you're not going to choose. Awesome. Number 13. Hey, we just did this. FOIL. First, outside, inside, last. First is what? 2m times 2m. 4m squared. What's outside? 2m times negative 4. 2m times negative 4. Negative 8m. What's inside? 4 times 2m. Positive 8m. What's last? Positive 4 times negative 4. Negative 16. The only like terms I have are my positive 8m and my negative 8m. Those cancel out. I have 4m squared minus 16. Okay, this one's worded weird. Look at number 14. 12a cubed b squared, and which below? So this one and which one of these have a GCF of 2a squared b? So this is the GCF, 2a squared b. I want to know which other one of these would have a 2a squared b as the GCF. So I'm looking and I'm saying, if this is the GCF, 2a squared b, there's for sure an a squared in here. And b, there's for sure a b in there. Because this has a to the third, so for sure it has an a squared. And this has b squared, so for sure it has a b to the first. But it also has to be something that goes into 12. Okay. Does this have a GCF? If 6 and 12, would I choose 2 as my GCF if I had a 6 and a 12, guys? No, what would I pick? I should have picked 6 as my GCF, so it's not A. It's not A because I could have picked 6 as my GCF. 2 and 4. If 4 and 12, would I pick 2 as a GCF? Could I? What would I pick instead? I would have 4 and 12. I would have picked a 4. So it's not B. How about itself? Can it go into itself? Yes. So C is an answer. $15. Super simple. Is the following a monomial, a binomial, trinomial? What is that? What is that? Write it down on paper. What it is. What it is. What it is. All right. Now I'm going to do number 7 on this paper that I'm giving you right now.
Might have been the printer, but they were down again.
Oh, thank you for remembering. All right.
I forgot you printed that dish.
If I get organized. All right. Oh, did you guys say trinomial? Okay, good. You're right. Okay, so there's that. Now, number 7. What does the graph of 2 to the x look like? You guys just graph it. 2 to the x, 2 to the negative 2, 1 over 2 squared. Remember, a negative exponent drops down. 1/4. 2 to the negative 1. What does the negative 1 do? What does the negative exponent do? Good. 2 to the negative 2nd equals 1 over 2 squared equals 1/4. 2 to the negative 1 equals 1 over 2 to the first equals 1/2. 2 to the 0. Anything to the 0 power is 1. 2 to the first, 2. 2 to the second, 2 times 2, 4. Ooh, I'm running out of ink. 2 to the third, 2 times 2 times 2. No. 2 times 2 times 2. What's 2 times 2 times 2? 8. Thank you. So graph that. Negative 2 and up 1/4. I need to refill my... Oh. Okay. 2 to the left and up 1/4. That's like hardly anything, you guys. Negative 1 up 1/2. Like you're not even at 1 yet. Oh, it's so hard when the graph's so small. Oh, there's my y-intercept. 0, 1. 1 times 2 to the x, remember? Graph the order pairs. Over 1, up 2. Over 2, up 4. Over 3, up 8. This is what the graph of y equals 2 to the x looks like. The asymptote is y equals 0. The domain is all real numbers. The range is y is greater than 0 or 0 to infinity. Low to high. Low to high. How does, number 8, how does 2x plus 3 differ from 2x? What did I do? This is a transformation. Two x plus 3, and this just says 2x. What does the plus 3 mean at the end? No, this would be left 2. 2 to the x minus h plus k. Remember that? What does the k do? Up or down? This is up 3. Number 9, you should be able to do fine. Remember, a subtraction sign means that I have to distribute the negative sign. Negative times x squared. Negative times negative 7. Be careful. Subtract negative 7 plus 7x. Subtract times a 5 minus 5. Sorry, they're different color ink. I'm just... Okay. Combine like terms. The x squareds go together. The x to the normal power, x to the first goes together. and the 8 and the negative 5 go together. So I'm categorizing it, I'm labeling. In standard form, x squared would go first. No. Thank you. What's 3x squared minus x squared? 3x squared minus x squared. 2x squared. Next is going to be my to the x first power. 4x plus 7x. What's 4 plus 7? 11x. What's my stars? Negative 8 and negative 5. Negative what? It's not 3. Negative 8 and negative 5, negative 13. But if it's multiple choice, I bet you one of the choices is going to have a 3 because people aren't going to pay attention. So it's like a distractor. It's there to trick you. Find the mistake. Something's wrong. What's wrong? Anthony. They didn't write it twice. Because if they would have written it twice, what would have happened? They would not have gotten that. What's the real answer when you write it twice and multiply it? It's called the difference of two squares. Work it out. What should they have gotten? Volunteer, what should they have gotten? Yeah.
X squared minus 10x plus 25.
Not the, x squared minus 10x plus 25. Yeah. So I'm sorry, this was not a difference of squares. I said that wrong. It's a perfect square trinomial. Finding the product. We did this, 3 weeks ago? Everything on one parentheses needs to be multiplied by all of the others. So you need to really make sure that you're multiplying out everything and then combining like terms. I'm going to stop. I'm not going to do that one because I need to talk to you about growth and decay on the backside. You can multiply and combine like terms. All right, turn the paper over. Growth and decay. This is where we've used our calculators and we have done a certain method. Remember? It all goes in perfectly. You have to look for words so you know growth or decay. Here's my formulas. P, is going to be my initial, what am I starting with? Hey, you guys, this says decreasing, and I wrote it in bold. What's decreasing, growth or decay? Decay. This is going to be P, 1 minus R to the T power. All right. What's my P, my principal? What do you start with? 15,000. A city has a population of 15,000 and has been decreasing at a rate of 4%. That'd be people moving. That's how populations decrease. You can't say people stop having babies because you can't stop fast enough. Like people moving or dying is the way it decreases. A lot of people are leaving California. So that's happening right now. 1 minus R. What's my rate? As a decimal. What's 4% as a decimal? 2 spaces to the left. 0.04. 1 minus 0.04. If this rate continues, find the population in 13 years. Whoop, to the power of 13. Here we go. Everybody have your calculator on? If this says write the equation only, I want to let you know that on the test, what if they say 15,000 and then they put, what's 1 minus 0.04? Do that on your calculator. Don't risk this mistake. What's 1 minus 0.04? It could be that if I have to write the equation, the multiple choice would have a 96 in there instead. So you don't know. 1 minus 400 or 0.96. Either one is write the equation only. Did you guys want to work it out? Because number 17 is the same type. 15, let's do 17. Growth. Here's the growth. P times the quantity 1 plus the interest rate. 4.6. Ooh, what's 4.6 as a decimal? You're like, it already is a decimal. I know, but how do I change this percentage to a decimal? What did I do here? How many spaces did I move? 2 to the left. Why 2? Because 100% has 2 zeros in it. 2 to the left. 12.046. So here's the equation for growth. The population of a town 7,000 grows at a rate of 4.6% per year. What will the population be in 10 years? What do I start with? What does the town start with? 7,000. 1 plus, because I'm growing, 0.046. What will the population be in 10 years? Okay, let's do it. 7,000. Put 7,000 in your calculator. Then put the parentheses. What? Well, you can. So I need to know that this is 1.046 to the 10th. Our calculators can do you remember the caret symbol? It's the upside down V. Do you remember this? This is the exponent. This is how you do an exponent of 10. This symbol right here. So you're going to push on that button, and it's going to be to the 10. So this does everything for you. $10,975. And you know what, you guys? There's no such thing as 0.26 of a person. But if you had like a basic calculator, I would have to do the 1.046 to the 10th power first. 1.046 to the 10th power first. And then I multiply that times 7,000. So I have to work backwards. If I have just a normal calculator, I do the 1.046 and then I go times 7,000. And look, it's like the same. 10,975 people. The population will be 10,975 people. So we've got graphing exponentials, FOILing, multiplying, adding, subtracting polynomials, growth, decay, changing a rational exponent into a radical, square root. Everything on this study guide is exactly what you'll see tomorrow. You need to do your best on this study guide. This is like not an option. 18 questions. The district does the point value. So the district grades it and the district does the points.